as you can see right now, the balloon is down, and you can see it start filling up. We heated the flask, and now it's going up. There you go. Notice that when temperature inside increases, the volume of the balloon also increases. This shows that the gas molecules gain kinetic energy and move a lot faster, causing it to spread out and fill up the balloon. As the temperature increases, the molecules move a lot faster, causing them to spread out more and fill up the balloon. Alright, let's take it and observe what happens as I submerge it into cold water, ice water. Notice that when submerged in ice bath, the temperature inside the flask decreases. The volume of the balloon also decreases. The gas molecules have less energy and move slower, causing the volume of the balloon to decrease. Okay, so right now I have here a soda can. I'm gonna fill this up with a little bit of water, and then we're gonna heat it up. As soon as we see a steam in here, we'll take it out and submerge it into our ice water. It's already steaming, so we'll see what happens if we submerge it into the ice cold water. There you go. Our can collapsed. The difference in pressure in and out of the can is ultimately the reason why the can collapsed. Okay, so this one is demonstrating boyle'slaw. So what we have here, we have a bell jar. This syringe is connected to this. But this is important right here because this one, as soon as you pull the syringe and push, this is a one-way valve, which means that it can only take air out. Okay, so as soon as we'll put the little balloon in here, is partially inflated. We'll put it inside, and then let's cover it. Screw this in. Okay, make sure it's tight. So let's start pulling this and observe what happens to the size of the balloon. Alright, so I'm gonna start. Now you can see that the balloon is getting bigger. Is bigger. Now notice what's going to happen to the balloon as we release this. So that means we're putting back pressure inside. Let's see what happens. There.
When I pulled the syringe, I took some of the air out, which means that there's less air inside, thus decreased the pressure. Notice that when pressure is decreased, the volume of the balloon increased. As we release the cover, we put the air back, which means we increased the pressure inside. Notice that increasing the pressure results to decreasing the volume of the balloon. The balloon is back to its original size. This shows that when pressure is up, volume is down. When pressure is down, volume is up. This is the inverse relationship of pressure and volume known as Boyle's law.